This video is super basic about correlation. We're not going to talk about how to calculate it or really where it comes from, just how to correspond the number value with what we would expect to see on a scatter plot. So here we have a bunch of scatter plots. And from the left, we have perfectly positive correlation. And as we go to the right in the middle, there is no correlation. And lastly, there's perfect negative correlation on the right. What we want to look at are the data points that we have on our scatter plot. But for simplicity, I think I'm just going to call them dots. So in this example, they line up in a perfectly straight line. It doesn't matter how steep the line is. It's not about whether it goes really steep or it's really shallow. It really is just about how well these points line up to make a super straight line. And if it goes at all uphill, making a super straight line, that's perfect positive correlation. In real life, that almost never happens. What we're going to see are something more like this, or even like this next one. And you can see it's still sort of a group of dots. They're basically going uphill, but it's more like this cloud of dots. They're not perfectly lined up in a perfectly straight line. Again, it doesn't have anything to do with how steep they are. Just if they go uphill as we move to the right, we're always reading left to right for this uphill, downhill. And do the dots gather together pretty tightly? The bigger the cloud of dots, the closer to zero I expect this number to be. And here at zero, there's just a scatter. The points are all over the place. It's not clearly going uphill or downhill. They're just everywhere. So this is no correlation. Whatever variable I have on this axis seems to have nothing to do with whatever variable is on this y-axis. And coming to the right, we see the mirror, except for now we're going downhill. As we move left to right, the points are going down. That's a negative correlation. And again, the value here, the 0.5 or 0.9 or 1, is just about whether those points line up into a perfectly straight line. The bigger the cloud of dots, the closer we are to zero. The only ones that are very clear, the only thresholds are 1, 0, and -1. We use these words at the top to describe it. We always want to be using 4 words to describe this correlation. Up here, I did not make this graphic. The place I found it from assumed we were only talking about linear correlation, so they've only used correlation. But I think you should be more clear anytime you're talking about this correlation coefficient, which is actually called Pearson's product moment correlation coefficient. Whenever you describe it, you want to be using 4 parts. The first part is the strength. Is it perfect? Is it strong? Is it moderate? Low? Whether you use the word strong or moderate or low is sort of up to you. There's no perfect boundary for what you call it. So if I had 0.7, would I say strong? Would I say moderate? There's not a perfectly clear rule. Lots of people will say lots of different things. So there's never a perfectly right answer. You go with what you think it is. If you want to call this strong, I think that could be a defensible position. If you want to say it's moderate, that's also defensible. You wouldn't say low and you wouldn't say perfect. Of course, we're only talking about like the 2 possible things on either boundary, that it's either strong or moderate. So the first thing you want to do is the strength. The second word you want to say is whether it's positive or negative. Positive is a positive number going uphill. Negative is a negative number going downhill. And then the last 2 words are always the same. It's always going to be linear correlation. So if I look at a scatter plot, I look at how the dots look, I could say, oh, this represents a strong positive linear correlation. I will use whatever comes with that type of scatter plot. But keep in mind, as I just said, these are for linear correlations. Take a look at this last row down here. Those scatter plots look super cool. They're clearly making patterns. There's some type of relationship happening. Something is happening. But the R value in all of these cases would be 0, because although there does seem to be some sort of relationship, something is happening between these 2 variables, it is not linear. They do not make a straight line, not like this is a circle. This is 4 different little clouds. This is making sort of like an upward facing and downward facing parabola. Here we have a sort of U shape. A pattern is happening, but it is not a straight line. And if it doesn't make a straight line, it is not linear correlation, and the R would be 0. So I cannot stress enough, that Pearson's product moment correlation coefficient is for linear correlation. Do the points in the scatter plot form a perfectly straight line?